This is lesson 6 on compound inequalities. A compound inequality consists of two distinct inequalities, and those two inequalities are joined by the word and or the word or. So let's see what happens when we join them with the word and. The graph of a compound inequality with the word and contains an overlap of the graphs of the two different inequalities. So let's see what we mean by that. If I'm going to graph x is greater than or equal to 3, then I'm going to have a graph that starts at 3, I'm going to look, it's going to be a closed dot at 3, and I need to shade. Let me pick a number. Let's try 6. Is 6 greater than or equal to 3? It is greater than or equal to 3, so I want to shade towards 6. Alright, so let's try this other one here. X is less than or equal to 7. So I'm going to put 7 here. 6, 5, 4. Let's go with 8, 9, 10. I'm going to look and I see that my dot's going to go at 7. It is going to be a closed dot. And now I need to figure out which way to shade. I'm going to pick the number 4. 4 is less than or equal to 7. That's true, so let me shade towards 4. So if I want both x greater than or equal to 3 and x less than or equal to 7, let's see what I have. Let me put 3 over here. 3, 2, 1, 4, 5, 6, 7, 8, 9. So let me graph the first one. I'll put the closed dot at 3. We already know that that's what's going to happen. We also know that there should be a closed dot at 7. Now from 3, I would be going to the right. This way. And from 7, I would be going to the left, so this way. And so I have this section right here between 3 and 7. I don't want anything to the left of 3 here, less than 3, and I don't want anything greater than 7. So it is the intersection of these two graphs. It is the part that where they overlap. That is my solution set whenever I have an and type of inequality. Let's see what an or inequality does on the right-hand side here. The graph of a compound inequality with the word or contains each graph of the two inequalities that form that compound. Okay, so it's the same kind of idea here. Let's see what happens. When x is less than negative 2, so here's negative 2, negative 3, negative 4. So I'm going to put a dot at negative 2. It is going to be an open dot because it is strictly less than. Now I'm going to try a number. Let me try 0. Is 0 less than negative 2? The answer is no, so I do not want 0. I want to shade away from 0, so it's going to go that way. Now let's try doing this one. X is greater than or equal to 1. So let me put 1 there, 0, negative 1, 2, 3. I'm going to have a dot at 1. It is going to be a closed dot at 1. And now I need to figure out which way I'm going to shade. Let me try the number 0 again. Is 0 greater than or equal to 1? No, it is not. So I need to shade again away from 0. So let's see what happens when I connect these with the word or. I'm going to need to have a negative 2. So let's start down here with a negative 2. So over here it'd be a negative 3. Let's go with negative 1, 0, 1, 2, 3, 4. Okay, so let's graph the first one again. This x is less than negative 2. We decided that was an open dot at negative 2, and we shaded to the left. And then let's try the other one. Let's see. So x is greater than or equal to 1. We decided was a closed dot at 1. And it's going to go to the right. And that is the solution set for this compound inequality. Notice they're going away from each other. I don't have this middle section. On this one over here, for the and, it is the middle section. It's where the two of them are the same. This will always be the case. You'll never end up having both inequalities going in the same direction. They won't both go to the left or they won't both go to the right. They'll either be opposites, going opposite directions, or they'll go towards each other. So in other words, this way they're both going like this, and this way they're both going like that. So away or towards. When we solve compound inequalities involving the word and, what we want to do is we want to break the compound inequality up into two different inequalities. So if you notice here, this says negative 3 is less than or equal to m minus 4. So let's first just take a look at that, and let's break that out. So negative 3 is less than or equal to m minus 4. We also see that we have this. M minus 4 is less than negative 1. So let's write that one out too. M minus 4 is less than negative 1. Okay, so I need to solve both of these inequalities. So this one on the left here, I want to get m by itself, so let me add 4 to both sides. Negative 3 plus 4 is 1. 1 is less than or equal to m. Then I can try doing this one over here. So let me add 4 to both sides. And I get m is less than negative 1 plus 4 is 3. So now what I want to do is I want to graph both of these on this number line here. So I'll graph the first one in red. 1 is less than or equal to m. So I have 1 is where my dot's going to go, and it's going to be a closed dot. So at 1, I'm going to put in a closed dot. And I'm going to need to shade, and for now what I'm going to do is I'm just going to look and say, okay, so m is greater than or equal to 1, let me put in the number 0. Is 0 greater than or equal to 1? No. So I'm going to eventually want to shade that direction. But I'm just going to put that there for now because I don't know how far in that direction. And you'll see what I mean in a second. Let me graph this piece now in orange. So m is less than 3. So I put a dot at 3. It is an open dot because it's strictly less than. So let me put my open dot right here. Let me still try a number. How about 0? Is 0 less than 3? The answer is yes. So I'm going to want to shade towards 0. In other words, I'm shading this whole thing between these 2 points. Like that. So the solution set here is from 1 to 3, not including 3. And that's all you have to do for compound inequalities involving and. Break it into 2 parts and graph the 2 parts. For compound inequality involving or, it's already broken into 2 parts for you. If you notice up here, we already have this piece. There's also this piece. So I simply solve both pieces. 3t plus 2 is less than negative 7 is one piece. And the other piece is negative 4t plus 5 is less than 1. Looking at the first piece, I would subtract 2 from both sides, telling me 3t is less than negative 9. I then divide by a positive 3. Think to myself, do I have to flip the sign when I divide by a positive? The answer is no. So I'm left with t is less than negative 9 divided by 3 is negative 3. Over on the right, I would subtract 5 from both sides first, leaving me with negative 4t is less than negative 4. I now am dividing by negative 4, so I think, do I need to flip the sign? Yes, I'm dividing by a negative number. So I'm left with t is greater than negative 4 divided by negative 4 is 1. So let's go ahead and graph this. So I want an open dot at negative 3 in orange here. Open dot at negative 3. And I want to see if is 0 less than negative 3. No, it's not. So I'm going to end up shading to the left. I want to shade away from 0. And for the red one, I'm going to have an open dot at 1. And let me try 0 again. Is 0 greater than 1? Again, no, it's not. So I'm going to end up shading to the right. So let's go ahead and do that. Let me shade to the right here. And let me shade to the left here. And so again, you see when we have an OR type of compound inequality, we will end up shading in opposite directions. So that's everything for today. Solving compound inequalities with and OR. There will be no check your understanding, and be ready to work tomorrow in class. All right, see you then. Bye-bye.